everybody, welcome to this video. In this video we are going to discuss about the conversion of galvanometer to ammeter. This is the setup that we are going to do it in the practical sessions, and the aim of the experiment is to convert the given galvanometer of known resistance and figure of merit into an ammeter of a desired range and to verify the same. The theory. What is a galvanometer? We know very well a galvanometer is a device which is used to detect a feeble electric current in a circuit. It has a coil pivoted. Pivoted is nothing but the suspended between concave pole faces of a strong laminated horseshoe magnet. When an electric current passes through this coil, it deflects. The deflection is proportional to the current passed. The galvanometer coil has a moderate resistance, about 100 ohms, and the galvanometer itself has a small current carrying capacity, that is 1 milliampere. What is an ammeter? Ammeter is a device used for measuring large electric currents in a circuits. For this purpose, it is put in series with the circuit in which the current is to be measured. How to convert a galvanometer into an ammeter? A galvanometer can detect only small currents. Thus, to measure large currents, it is converted into an ammeter. It can be converted into an ammeter by connecting a low resistance called shunt resistance in parallel to the galvanometer. Let G be the resistance of the galvanometer and Ig be the current for full scale deflection in the galvanometer. The value of the shunt resistance required to convert the galvanometer into an ammeter of 0 to I ampere, that is S is equal to Ig into G1, that is Gi minus Ig. Ig is calculated using the equation, that is Ig is equal to N into K, where N is the number of divisions on the galvanometer and K is the figure of merit of galvanometer. Now, what is the figure of merit of a galvanometer? The figure of merit of a galvanometer is defined as the electric current required in producing a unit deflection in the scale of the galvanometer. It is represented by a symbol K and is given by the equation K is equal to E by R plus S into theta, where E is the EMF of the cell and theta is the deflection produced with resistance R. Let L be the length of the resistance wire required for a resistance of S ohm. Then L is equal to pi r squared S by rho, where R is the radius of the wire and rho is the resistivity of the material of the wire. What are the materials are required? Galvanometer, cell, that is battery eliminator, rheostat, which is used to vary the resistance of the material, and ammeter of desired range, resistance wire, one-way key, screw gauge. The procedure is going to be the shunt resistance, that is the low resistance box, is act as a shunt resistance required to convert the galvanometer into ammeter of range. I is calculated using the formula S is equal to Ig plus G, that is Ig into C by I minus Ig. Here G is the resistance of the wire of G is the resistance of the galvanometer, I the resistance of desired ammeter, Ig is equal to N into K, The current required to fill scale deflection in the galvanometer. When n total number of divisions in the galvanometer, k the figure of merit of the galvanometer. Then the length of the wire required for a shunt can be calculated using the formula, that is L is equal to pi r squared S by rho, where rho is the resistivity of the material and the wire of the radius. The radius of the wire, which can be measured using the screw gauge. Cut the resistance wire at a length of L plus 2 centimeter. Make two marks near the ends of the wire so that the distance between the marks is exactly L centimeter. The wire is now connected to the terminals of the galvanometer so that the marks are just outside the terminals of the galvanometer. The galvanometer with shunt connected across its terminals is the converted ammeter of the desired range. The connections are made as shown in the diagram. The resistance and the EMF, the key and the ammeter, galvanometer and the shunt resistance, that is low resistance box, also is connected here. The galvanometer with the shunt resistance is connected in the series to a battery through an ammeter, key and a rheostat. Insert the key, adjust the rheostat and set the current reading I of the given ammeter at the particular value. The reading of the galvanometer Ig is noted. Now the current through the converted ammeter is calculated using the relation I dash is equal to Ig G plus S by S. The error of the converted ammeter is calculated as I minus I dash. Repeat the experiment by changing the rheostat resistance. A graph can be drawn with I minus I dash along y axis and I dash along x axis. This is called the correction graph. Thus, the converted ammeter is verified with an ammeter of the same range and a correction graph is obtained. Observations: resistance of the galvanometer G is equal to dash ohm. Figure of merit of the galvanometer K have to be calculated. Number of divisions in the galvanometer scale N have to be, and the current for full scale deflection Ig is equal to N into K is equal to dash ampere. Decide range of the converted ammeter I is equal to dash milliampere. Shunt resistance have to be calculated with the help of the formula, that is S is equal to Ig into G by I minus Ig. It should be in ohms. See the table. So in the first one, the trial number have to be, and the ammeter I in amps have to be calculated. The galvanometer reading should be noted. The current through the converted ammeter I dash have to be calculated with the help of the formula, and the error of the converted ammeter I minus I dash have to be written. Calculations: shunt resistance S is equal to Ig into G by I minus Ig have to be calculated. The radius of the wire R have to be written in centimeter as well as in the meter. Resistivity of the material of the wire rho have to be calculated, and the length of the wire required for shunt can be calculated using the formula L is equal to I by pi r squared S by rho, and the precautions should be noted down. All the connections should be neat, clean and tight. The EMF of the cell should be constant. The ammeter used for verification should preferably be of the same range as the range of conversion. The diameter of the wire to be used for a shunt resistance should be measured accurately. Length of shunt wire used be neither too small not too large. The resistance box should be a high resistance one. The voltmeter used for verification should preferably be of the same range as the range of the conversion. The value of required series resistance should be calculated accurately. And the result, the given galvanometer is converted into an ammeter of range 0 to dash ampere by connecting a shunt resistance of dash ohms. The learning outcomes, a student learns the following concepts: galvanometer, ammeter, figure of merit, shunt resistance, how a galvanometer can be converted into an ammeter. Thank you.